prefer that the questions be intermixed with the discussion. With that, Steve Hand, one of the co-founders of Xen Source, and therefore, approximately speaking, one of my bosses, is going to be speaking to us about the wonders of Xen and para-virtualization.
Thank you very much. I'm happy to take questions whenever anybody wants. I'm not sure quite what level to go at, so we can dive down or we can come up. Well, I've only got, what, 15, 20 minutes anyway, so it'll be, by necessity, a whirlwind tour. There is a longer meeting dealing with this stuff in more detail in January, it was mentioned. So I'm going to talk about basically principally Xen, but at the start I'm going to try to give it a rough overview of what virtualization is and what I mean by virtualization, why it's useful, interesting, cool, whatever, what sorts of things you might be able to do with it. I'll then talk a little bit about the Xen architecture with particular focus on what we've done in our most recent release of Xen 3.0, which was released last week. Then if I've got time, I'll go through a particular case study. One of the things that we think is really nice with Xen, which is basically live VM relocation, moving a running operating system and all its apps from one physical host to another with almost zero downtime. And then I'll take any questions. But as I said, if you have questions in between, please just shout out. So, what is virtualization? What do I mean by virtualization? It gets used in lots of different spaces. I'm talking about operating system virtualization or platform virtualization. So not storage particularly or network, though these also get rolled in, as we'll see. And there are various ways of doing this, various techniques people have used in the past. One is you take an existing OS and you modify it somewhat, or you add some features to it, so you can basically hide the namespace or hide processes from each other. So things like jail, or sort of a primitive version of this. There's also things like Virtuoso, vServers for the Linux, there's a patch for the Linux kernel, Solaris zones. These sorts of things allow you to divide up your OS into multiple different domains. You may have root in all of these domains, and processes only see what they're supposed to see. And that's pretty good. And the problem with this is it's very hard to get strong isolation, particularly fault isolation or performance isolation between things running in these different zones or different partitions. Because everything's really actually running in the same OS. And that means you're sharing your buffer cache, you're sharing, in many cases, scheduler queues, spin locks, a whole bunch of other stuff. So you're going to get some contention. It's hard to keep the performance of different sets of processes separate. Another technique that people have used in the last few years is full virtualization of the x86. Now, again, virtualization in this form has been around for donkey's years, 35 years or so since IBM first kind of did it. But on the x86, it hasn't been around that long. And it turns out that this is because the x86 is very difficult to virtualize effectively. There's a bunch of instructions which don't do the right thing. They don't trap when they're supposed to trap, they just do the wrong thing. And this means that if you run your OS in an unprivileged mode, it doesn't work. So you can get around this by doing full emulation, like QEMU, for example, or Box, which is a slower, perhaps more faithful emulation. Or you can use sort of task switching tricks like Virtual PC. Or you can do what VMware do, which is basically do binary rewriting. You basically scan the memory, you rewrite stuff, you get rid of these pesky instructions, and you replace them with something else. And this is really, really cool technology, and it's very, very, very difficult to get right. It's very difficult to make sure it's robust, and it tends to have a big performance penalty. So, rather more recently, a new sort of trick, or a new word perhaps for an old trick came on the scene, which is power virtualization. This is what we do, it's what UML kind of does, and it's what we do in Xen. And the idea here is that you cheat. You basically take your OS, you say, I'm going to modify my OS just a little bit so that it knows it's running on top of a virtual machine monitor. It knows it's being virtualized. And that means I'm going to get rid of those instructions. I'm going to take a certain place where I know I would trap, and maybe I'm going to replace that with a explicit program trap.
Rid of them from the kernel.
Get rid of them from the kernel, that's correct. And by doing this, you're not actually sacrificing safety or anything else. What you're doing here is making sure that by doing some sort of co-design between the OS kernel and the hypervisor, you're going to get really, really good performance. And it turns out you don't need to do an awful lot. You don't have to make very many modifications to make this work really, really fast, as I'll show. So if you do have virtualization, this is a sort of a marketing slide, I hope it doesn't offend you. what can you do? Well, one of the things you can do, which is one of the primary uses, I guess, that people have been seeing for server virtualization so far, is to do server consolidation. So you've got a bunch of machines out there, particularly if you've got Windows-style machines, but even other ones, you've got them running perhaps at 5, 10, 15% maybe tops load. Not all of them. There's a bunch of them sitting there, and you can't put them together because they conflict in some way, or they're performance critical, you need to have performance isolation. So you can somehow consolidate these things by moving the operating systems and the applications onto a single physical host, and now you've got 2 free boxes, and you save yourself power, you save yourself cost of running, or you can increase your capacity. You can also avoid downtime. So one problem right now is if you want to take a machine down for maintenance, you want to stick in a new disk, you want to fix a problem, physical problem in the box, is that everything running on that box goes away, and we end up scheduling it at like 3 o'clock in the morning on a Sunday. One thing you can do, again, hopefully with virtualization, is you can just move your running applications, your OS, everything, the entire thing, onto another box. And then you can go and service or take that thing out of service or replace it or upgrade or do whatever you want to do. You can also, you get a bit friskier, take a data center where you've got a whole bunch of physical boxes, and you can track what's going on with your workload. You can see how well your application is performing, how well your operating system is performing. And if they need a bit of a speed boost, or they need something else, or perhaps they're not using enough, you can really start to move these things around the data center to try to optimize or to load balance across the entire system. And then finally, you may be able to enforce a security policy. One thing we have to do a lot of is patch systems which become vulnerable in some ways. And often this can be intrusive, and if we've got a situation where users are allowed to administer their own systems, it can become almost impossible. One thing we have here is the ability to do something outside of the OS. You can give somebody their entire OS, you can give them a root password, they can install whatever they want to, and you've got a point of presence outside of the operating system where you can actually go in and patch or prevent, I think this is supposed to be a worm, to stop it actually from spreading. So you can put in a packet filter, you can put in a snort rule, you can do whatever you want to outside of the operating system. Okay, so, oh yeah, that's what I was doing, good. Okay, so that's the why you want virtualization, and a lot of people are interested in it. There's a lot of people out there trying to do it. And what I'm going to do for the rest of this talk is really just focus on one solution, which is a solution we provide, which is called Xen. And Xen's been around for a little while now, and we recently, as in last Monday, finally shipped the open source 3.0 release of Xen, which was a little bit late, as sometimes happens in these projects, but we got there in the end. And what this provides is, as I said, secure isolation and resource isolation between virtual machines. So you've got virtual machines, you can give them a certain amount of memory, a certain amount of CPU allocation, a certain amount of disk bandwidth, and so forth. And you're guaranteed that that's not going to be violated by something running in a different virtual machine. So it's quite strong. It's been designed from the ground up to do that. The current code base supports mostly x86 architecture, so the primary stuff out there, and 32-bit PAE, so for larger than 4 gig machines, and also 64-bit mode, if people are using that. Plus we've got support for VTX, the new extension from Intel, and I'll talk a little bit about that in a moment. There's also there in gray, there are people working on an Itanium port for this, which is at a reasonable stage, it kind of works. And also for power, actually some people in IBM are working for that, and that code is not yet being released publicly. All the other code is public. Power code is still being cleaned up or whatever else. But we hope to have support for all of those architectures really soon.
Is Xen by Endian?
Is Xen by Endian? Well, when you have an individual instance of Xen, it won't be, but we can deal with these things on different architectures. I'm not sure if I understand your question.
No, you answered the question.
It's
Okay.
per Endian.
It's per Endian, yeah. Oh yeah, sorry, I should point out, yeah, on x86 you get to run x86 operating systems apps, it's not a complete mix and match because it's not an emulation environment. So this is, as one of the questions said beforehand, the key thing is that only the guest kernel needs to be ported. So you need to make some modifications to the guest kernel, Our focus is on Linux because we know it pretty well and a lot of people use it. But there's also work on FreeBSD, NetBSD, Plan 9, and Sun have recently announced a Solaris x86 port. Yeah.
Once you get this running on a platform,
Yeah.
does all the is it guest kernel agnostic? So as long
Yes.
as those guest kernels support that particular.
That's right. So that's one of the advantages of this over like the single OS thing. You can put a Xen box down there and you can run, for example, multiple different versions of Linux, a FreeBSD instance, a NetBSD instance, a Plan 9.1,
Anything
and so
that would
forth.
be native on that platform.
Correct. Yeah.
Which makes one of the handier purposes for it buying some really incredibly cool bleeding edge instance of BayLIR and it really only having to be one.
Right. Yeah. No. This is. I mean, for a lot of the time, for this stuff. I mean, this is the sort of technology. I mean, the big iron guys have had for a while. I mean, if you buy a P series box,
70, 60.
indeed, P series box, will do this stuff. So the key thing is that this is x86. Though they have moved, as I said, IBM are actually now going to release their code with into Xen effectively. So the P series hypervisor is going to be open source, which is great.
Well, it won't be running native though.
It will be running on power boxes.
But sorry, it won't be running Xen native. It'll still be running whatever the base OS is.
It will. Oh, okay. I think it'll become clear on the next slide or so.
Well, for
where
them,
Xen
I meant,
lives.
yeah.
Yeah. So the good thing about this is that you modify the kernel. Okay, you have to have the kernel source. You have to do a bit of work, but you do it once. You modify it, and then the user level applications, the libraries, everything else you want to run just installs and runs just like normal. It looks identical pretty much to a regular machine. Very, very good execution performance. This is partly because of this power virtualized thing we do. We've got broad Linux, so approximately the same as Linux hardware support, and as I said, we've got this feature, this live relocation of virtual machines between Xen nodes. Okay, so hopefully this picture will explain. This is like roughly the architecture of what's involved in Xen. So the bottom, hardware. We're focused on server hardware. This is mainly a server product or whatever, though you can run it on your desktop if you want to. So we deal with SMP up to 32-way boxes. We deal with SCSI, Ethernet, whatever, all your standard stuff. And then we've got this Xen layer here in the middle, and this is really small. This is about 30,000 lines of code right now, and that includes all the archaic 16-bit startup code and a bunch of sort of ACP table reading and PCI config stuff, or not even too much of that, which is only run once. So it's a very, very small hypervisor, and it doesn't do anything on its own. If you bring Xen up on the box, it just sits there. That's all it does. And in fact, what we have here on the left-hand side is a special guest operating system. So VM0 here, we call it domain 0 internally. The terms are sort of interchangeable. And this is basically in our case, it's nearly always a Linux operating system. 2612 is the current one that we kind of ship, which just boots up, or Xen basically will bootstrap up after it's come up. So Xen will just do a little bit of stuff, it'll basically allocate some memory, and then you basically fire up this domain 0. And this runs your native device drivers, it runs all the daemons, anything you want it to run. It can have all the physical memory, and it can give some of it back, or it can have a limited amount, whatever you like, and it can have, you can use one or more CPUs of the physical machine. And it also runs a bunch of software, some user space software to do control plane operations. So that this is how you're going to be able to create another virtual machine, or to change the size of that virtual machine, give it more memory, more CPU, less CPU, hot plug a CPU, hot plug a device, whatever, these sorts of things. And then what we're showing here on the right-hand side, the 2 and 3, these are both unprivileged guest operating systems. So the VM on the left-hand side, VM0, is privileged in that it has the ability to create and destroy other virtual machines. You don't want to give this power to everybody. So most virtual machines are unprivileged. And the picture here of VM2 is a unprivileged SMP guest. So you can have up to 32 virtual CPUs in the guest, and these can be mapped to physical CPUs any other way you want. So you can have a 32-way CPU box which is on 2 CPUs, or 11-way on a 3-way box, or whatever you want to. They don't all make sense, but you can do it. And this is a para-virtualized guest, which means that it's been modified slightly so that it can talk, knows it's on top of Xen, and can actually get really, really good performance. On the far right is a new feature for Xen 3, which will be of more interest once the hardware becomes really widely available, which is the ability to run unmodified guest operating systems. This means you take your completely proprietary operating system, where Microsoft wouldn't give us the source code to Windows for some reason, and you take that, you bundle it up, and you run it inside this VT context, this VMCS, which is enabled by Intel's VT extensions, or by Pacifica's HVM extensions, which are coming out pretty soon too.
This requires special hardware?
This requires new hardware. So every server chip by the end of 2006 shipped by Intel, in fact every chip shipped by Intel by the end of 2006 will have this, and you can buy them you can order them right now.
Vanderpool stuff?
This is Vanderpool, that's right. And the Pacifica stuff is supposed to be first half 2006. So this is stuff that you can get, coming through. If you don't have that, you can't do the unmodified stuff. Yeah.
This begs the question, can you tap into the hardware calls underneath the unmodified guest OS to see how it's talking to the hardware?
Absolutely. Well, there's a lot of really cool stuff you can do even without the full virtualization stuff. Yeah. So in fact, I'm not sure if I have a slide on the details of that later on. In the VM2 case, this para-virtualized guest, it will invoke hypercalls, which are basically explicit system, the same as a system call, basically from the kernel down to Xen to do certain things. On VM3, it won't do any of that stuff itself. It'll basically just try to read and write pieces of device memory. It will try to update its page table base register, do all this kind of stuff. That will cause a trap with the VT hardware, which will then get emulated or fixed up in some fashion in the hypervisor and you resume. Yeah.
So that slide isn't quite correct. The front-end drivers actually go in the VTX, not in the unmodified OS.
Well, actually, that slide is correct, but I haven't explained that bit yet. So the device model for Xen 3 is that we wanted to reuse Linux device drivers where possible. So you've got your native device drivers here, and to be able to share those, because you've got a SCSI device or a network card or whatever, we basically have a back-end driver per device class, typically, as in an instance per device class, but it can deal with multiple devices, which is connected via these orange lines, device channels, to a front-end device driver. And what that means is that if you look inside a guest, an unprivileged guest, it will have a XenNet driver. And the XenNet driver will be ETH0 or ETH whatever, not as many as it likes. And that gets plumbed through via effectively a shared memory mechanism to the back end, and then gets bridged. We actually use all the Linux standard bridging tools in there. By default, gets bridged onto the external network or one or more of the external networks. You can also have a routing setup in there using the standard routing tools, or you can do NAT or whatever else. With the VT stuff, to get to your question, one thing we can do is we can actually write, even though we can't modify Windows, we can actually write a Windows device driver. And we can write a Windows device driver that knows it's running on Xen. So you can install a Windows device driver, which then basically does this para-virtualized thing. Does that make sense?
So then it is a modified guest OS.
The guest itself is unmodified. What we mean by unmodified guest OS is that you basically take retail media and you basically just install it and you don't do anything else. And it's a proprietary OS that we haven't actually modified. But you can install a driver into it afterwards. Yeah.
But you still have to install the drivers in order to be able to install it?
No, you
Just
don't
like
have
you
to.
would with most of the hardware you buy for Windows.
Right.
You have a little driver.
Plug a
that
USB
comes
gadget
with
in
that.
and you want
But
to
in
It's
fact,
exactly the same as if you had a physical physical card that said, this is VMnet manufacturing ETH0.
But those come with
Plug that
Windows,
in.
don't they?
No, actually, most of them come with the hardware you buy for Windows. They
But
have
also-
separate little disks, and you have to install their drivers.
But also, sorry, that picture, that's the optimized version. You don't have to do that if you don't want to. We can emulate every single device access if you want to. And in fact, that's the default configuration. So, because when you boot the first time, you may not have time to install these drivers yet. So when you do that the first time, every time you do an IMB or every time you do a PCI config read or write, every time you do any of these things, it traps into Xen and actually get passed up to a device emulation layer, which models a PCNet32 card, the BIOS, an 8259 PIC, a few things like this. This is slow because you're doing it for basically every little memory operation in and out, and you've got a big state machine which is trying to pretend to be some crappy old hardware.
Right.
So that's what you want to replace it with
You
this.
can run without the front-end
Correct.
device drivers,
Yes,
it's
you
just an
can.
optimization.
Correct. Yeah.
Cool.
Yeah.
Can you explain how you deal with like a Win modem where the guest OS doesn't understand how to use it, but your unmodified guest, you're basically your master program doesn't have any clue as to how a Win modem works. But
I don't have any
SBC
clues as to
does.
how
The same way you
works.
deal with a soft
Well,
modem when you.
The good thing is that this is for server hardware, which doesn't really ship with Win modems. But the key thing is your back end needs to be able to drive the hardware you've got.
Okay, so
Okay.
anything that works under Linux is okay.
So in this model, out of the box with Xen 3 today, this is Linux. That's Windows. So this is basically Windows with the device support that Linux has got. Yeah.
So does Xen automatically propagate these virtual device drivers up to the guests, or
Yes.
is porting required?
Sorry. If you just take an unmodified OS and you run it, it will discover via PCI config that it's got this device and that device, load its standard driver and just run that, and that's what Xen will do. Is that what you meant?
It's
You
going
don't
to
do
think it
anything
has
else.
the same hardware, not different hardware.
Yeah.
Okay, so it doesn't require any special device driver be loaded
No.
as a front-end device driver?
That's correct.
Don't forget, we do have January.
Yeah, we've got to drill down on January. Sorry. Yeah.
Yeah, I'm gonna try to be really quick. So, isn't the back-end driver become a giant IO empire flag and screw up NP scaling?
Well, it depends on how you pull it out. So one of these is going to be one-to-one with a physical device driver. So if you've got a physical device driver, which is, let's say, bound to a single CPU, as you've done IRQ Affinity, then the back end will run on that CPU as well, and everything will go through there. So yes, all of your I/O will end up going through this, or the guy I didn't talk about, VM1, because this doesn't work in 3.0. It's in the architecture, but it isn't quite working yet, which is a driver domain. So what you can do is you can take an individual device driver, or a set of device drivers, and put them into their own kernel space only virtual machine. It's a fairly small footprint, and you can basically deal with driver crash and restart without affecting any of the running guests at all. So, and obviously another thing you can do is you can use that to load balance across wide MP if you've got it. Okay.
You used a second word when you first described this. Driver something?
Domain. Sorry.
Domain, okay.
Yeah. Internally, they're domains. They're virtual machines. Virtual machines actually what's inside the domain. Domain's a process, and virtual machine is the program, if you like. So it's kind of process program thing. Okay, I have a lot of slides, and I'm not going to get through them all. I've talked about this. I've talked about this. This one here this is a little bit out of date.
Yeah,
I
about
do not
5 more
have
minutes.
results for Xen 3 right now. I was expecting to be a little bit worse than this, but this is just showing 4 different scenarios. On the left-hand side here, we've got native Linux. This is our baseline. It's always 1.0. The next bar is Xen. The next bar is VMware Workstation, white null version, which is the only version of the VMware product we're allowed to benchmark. So we will benchmark a new one when we let and UML. And what it's showing is each of these clusters of bars is showing a different workload or a different sort of experiment. And on the left-hand side, we've got spec int 2000. This is CPU-intensive stuff. It's gzip, whatever. You spend hardly any time in the kernel. You would not expect any virtualization technique to do badly here, and they all do really, really well. This is great. Then we've got like a Linux build. It's not really a benchmark, but basically, just trying to do a Linux build. And what you'll see is now you're going to be doing some I/O. You're going in and out of the kernel. You've got some system calls and stuff. And Xen basically takes a hit of a couple of %.
Not according to the numbers.
Yeah, well, that's the subliminal Internal marketing time.
Are we not supposed to notice this? Are we supposed to be good Americans?
I think that's supposed to be the other way around. Anyway. Damn PowerPoint. The numbers are getting bigger.
Yeah.
This is build time. Yeah, there you go.
Yeah.
Yeah. Okay. Thank you. I should know what these mean. VMware takes about a 20% hit in this particular benchmark, and as I said, this is an older version of their stuff. And then UML gets a bit hammered.
Yeah.
Then we've got a maybe a more realistic workload than that, a transaction processing workload. This is doing the OSDB stuff. Xen takes a bigger hit, it's more intensive. The other guys really are lost in the dust. And then spec web, which was an interesting one for us to do because there's some computation, there's some networking, there's a little bit of disk stuff as well. And again, we do very, very well there. As I said, these numbers are slightly old, but I would expect that we would be no worse than a couple of % on any of those particular things right now.
That's impressive if it's true.
It is true. So therefore, it's
I won't change my
impressive.
statement.
I can tell you that it feels really spiffy when you're actually working there on a machine and it's got some work going on
Yeah.
screen, and the guy in the queue next to you tells you that he's moved it to 4 different places around the office and you don't know where.
One of the scariest things, which we don't put on slides because we don't really understand it quite yet, is that we actually outperform Linux sometimes. But anyway, that's
It happens.
yeah, it happens.
Yeah, we've seen
Okay.
it.
Okay, I have about -2 minutes, I think. A couple of quick things that are interesting in Xen 3. If any of you have played with Xen 2, these are new things. One is guest kernels, which can be SMP. So we can do virtual SMP. It's actually up to word size. So on 64-bit, you can have 64 virtual CPUs and 32 on 32-bit. And this is all done via hot plug. So you can basically hot plug up or hot plug down a vCPU if you feel like at any time. You can pin an individual vCPU to a processor, or you can give it a percentage of that processor, like 33% or 50% or whatever. And this is actually one of the places where we found that for many applications, running, let's say, 4 two-way guests does an awful lot better than running Linux 8-way or whatever else. And these 2-way, 4-way, 8-way things, certainly for the x86 market, are becoming, of course, more and more easy to stumble upon because you get HT and multi-core and all this stuff. Yeah.
What does IPI stand for?
Oh, sorry, that's an inter-processor interrupt. So these are expensive things to do in real SMP things, and we can basically do a batching thing, which is what you would do in hardware if you thought of it. This is my final slide. No.
I would like to remind everyone that if you found this even the tiniest bit fascinating, you should make sure to come next month because we're going to have all sorts of gory detail. Deep magic, because Sean Perry is going to come and tell us all sorts of extra goodies.
Yeah.
Could we get the slides?
Oh, absolutely. So the reason I didn't send them is because I was writing them.
That's okay, I'll come around.
Quarter after 7.
We all do that.
I'll send these.
Let's let him finish this slide.
I'll finish this slide. This is just for, I don't know how much people here know about VT or HBM. It's still a bit of a mystery to most people because nothing really uses it right now, except for Xen. And what this does, in a nutshell, is actually not that sexy, except what it allows is. And all it really does, it takes these problematic instructions, these 17 instructions, in fact, in the x86 architecture, they didn't bother making virtualizable, and it allows you to trap them and a whole bunch of other stuff safely. You can configure this. And what this means is that you can now pretty much have an entire ring 0, 1, 2, and 3 in the x86 world in an unprivileged space. And then you can have a real 0, 1, 2, 3, the root context, as they call it, which is where Xen itself runs. And you can have as many of these things as you want to. Not only that, one of the nice things is that each of these, because it's a separate x86 box, can actually be running in a different mode. So you can actually have a, let's say, a 64-bit host, and you can run some 32-bit guests, or you can run the kernels and apps, or 64-bit kernel, 32-bit apps, or PAE, and you can mix and match these any ways you want to. And this is a really nice way of sort of transitioning towards 64-bit hosts if you find you've got a whole bunch of legacy apps which are 32-bit.
Is this Intel CPU showing up when?
This Intel CPU is ready to order right now. Unfortunately, they made a bit of a mistake, and they put this technology into the client processors first. So you can buy P4 VT boxes if you wanted such a thing.
But you can't get Xenons.
You can't get.
What about, I presume AMD will be implementing
AMD's things coming out, you can snip that out, thank you. AMD's is coming out first half 2006.
Excellent.
I don't have a ship date for that. They haven't given a ship
We
date.
really
Okay.
have to.
That does things, and then there's this other stuff. This is
All sorts of cool stuff will be included in the slides that will be available on the website.
Come back next month.
Can you?
Or you
This
can
is live
pin him during
migration.
pizza's
Quake
portion.
3 game. We had grad students lining up to be in this experiment, playing Quake 3 as we live migrate. things
Okay, so
around
that's
here.
cool.
I'm not going to be here in January because I have to teach class. These are all the people who we love, and yeah, download it. This is free. Go to the website, download, play.
We had
with
this
it.
great
There's a
release
test-
last week. The torrent's full.
We are looking for sysadmins and kernel hackers. Send your resume or expressions of interest to careers@xensource.com. We're up the road. We're just in Palo Alto, east, not really East Palo Alto, Bayshore it's called now. Download thing. There's a demo CD which you can just burn and just stick it in without muck with your machine. Just put it in there, play around. It's great. Thank you very much indeed.